Nothing in the universe moves faster than light. This statement is not a conjecture or a convenient approximation. It describes a fundamental boundary written into the structure of reality itself. The speed of light, approximately 300,000 kilometers per second, represents an absolute threshold that no object, no signal, and no form of energy can cross. This limit was not discovered through engineering failures or technological constraints. It emerged from a radical reimagining of space and time. Albert Einstein did not impose this speed limit on nature. He revealed why it must exist. His theory of relativity demonstrated that the constancy of light speed forces a complete revision of how motion, time, and energy relate to one another. The universe does not forbid faster than light travel through arbitrary rules. It forbids such motion because the very fabric of space-time makes it impossible. Before Einstein, physics operated under assumptions that seemed both intuitive and unassailable. According to Galilean relativity, velocities simply add. A person walking forward on a moving train travels faster relative to the ground than the train itself. The train's speed and the person's walking speed combine. This principle appeared universal. If light were simply another moving object, its speed should also combine with the motion of its source. A beam of light emitted from a moving spaceship should travel faster than a beam emitted from a stationary platform. Yet experiments suggested otherwise. In the late 19th century, measurements of light speed yielded the same value regardless of the motion of the source or the observer. The Michelson-Morley experiment, designed to detect Earth's motion through a hypothetical medium called the ether, found no variation in light speed. This result was profoundly troubling. If light always traveled at the same speed, the familiar rules of velocity addition could not hold. Classical physics offered no explanation for why light behaved this way. The problem was not merely technical. It indicated a fundamental gap in the understanding of motion itself. Einstein's solution came in 1905 with the publication of Special Relativity. He began with a simple but radical postulate. The speed of light in a vacuum is the same for all observers, regardless of their motion. This was not a hypothesis to be tested later. It was an axiom from which the rest of the theory followed. If light speed is constant, then something else must change. Einstein realized that time and space themselves must be flexible. When an object moves relative to an observer, time slows down for that object, and distances contract along the direction of motion. These effects are not perceptual illusions. They are physical transformations of the geometry, connecting events. A clock moving at high speed literally runs slower than a stationary clock. A ruler moving at high speed is literally shorter than one at rest. The faster the motion, the more pronounced these effects become. As an object's velocity approaches the speed of light, time dilation and length contraction grow extreme. At the speed of light itself, time would stop entirely and distances would collapse to zero. These transformations preserve the constancy of light speed. They ensure that no matter how fast an observer moves, measurements of light always yield the same result. The universe maintains the speed of light by altering the very dimensions in which motion occurs. The constancy of light speed imposes another consequence. Accelerating a massive object to that speed requires infinite energy. Einstein's famous equation, E equals mc squared, reveals the relationship between mass and energy. As an object accelerates, its kinetic energy increases. In classical physics, this energy grows without bound but remains finite for any finite speed. In relativity, however, the energy required to accelerate an object does not simply increase. It diverges toward infinity as the object's speed approaches light speed. The closer an object gets to this threshold, the more energy is needed to push it even slightly faster. At 90% of light speed, the energy requirement is already enormous. At 99%, it is vastly larger. At 99.9%, larger still. The progression has no upper limit. Reaching the speed of light itself would demand infinite energy, an impossible requirement. This is not a matter of insufficient fuel or inadequate propulsion systems. It is a structural impossibility. Mass and energy are intertwined in such a way that the universe simply does not permit a massive object to reach light speed. Only massless particles, such as photons, can travel at this speed, and they must always do so. They have no rest frame. For anything with mass, the speed of light remains forever out of reach. The speed of light does more than govern motion. It protects the logical order of events. In relativity, cause and effect are preserved by the principle that no information can travel faster than light. If signals could exceed this speed, the temporal sequence of events would become ambiguous. An observer moving in one direction might see event A occur before event B, while another observer moving differently might see event B occur before event A. If the two events are causally connected, if A causes B, this reversal would produce a contradiction. A signal sent faster than light could in principle arrive before it was sent. It could influence events in its own past. This scenario does not merely create paradoxes for storytelling. It violates the consistency of physical law. Relativity forbids such violations by ensuring that cause always precedes effect in every reference frame. The speed of light is the speed at which causal influence propagates. It is the maximum rate at which information can move from one point in space-time to another. This connection between light speed and causality means the limit is not arbitrary. It is necessary for the universe to maintain a coherent structure. Einstein's theory did not rest on abstract reasoning alone. It made precise, testable predictions. Particle accelerators provide some of the most direct confirmations. When protons or electrons are accelerated to speeds approaching light speed, their behavior matches relativistic predictions exactly. The energy required to increase their velocity rises sharply as they approach the threshold. Just as the theory predicts, no particle has ever been observed to exceed this limit. Time dilation has been confirmed through measurements of unstable particles called muons, produced in the upper atmosphere. These particles decay rapidly. At rest, they would not survive the journey to the Earth's surface. Yet moving at near light speed, their internal clocks run slowly enough that many reach the ground before decaying. The global positioning system relies on corrections for both special and general relativity. Satellites in orbit experience time at a different rate than receivers on the ground. Without accounting for these effects, GPS coordinates would drift by kilometers each day. The system works because the relativistic predictions are accurate. Every high-precision experiment conducted in the past century has reinforced the same conclusion. The speed of light is an inviolable limit. More than a century after Einstein's work, no observation has challenged the universality of the light speed limit. Advanced theories in physics, including quantum field theory and general relativity, incorporate this boundary as a foundational element. Speculative ideas occasionally propose exceptions, wormholes, warp drives, exotic forms of matter that might permit shortcuts through space-time. These concepts remain theoretical. They have not been realized, and many face insurmountable obstacles even in principle. Distinguishing between speculation and established physics is essential. The speed of light as a limit is not speculative. It is embedded in every confirmed theory of modern physics. It governs the behavior of particles, the propagation of forces, and the structure of space-time itself. The boundary stands not because alternatives have been forbidden by decree, but because no evidence supports their existence. The speed of light is not a speed limit in the ordinary sense. It is a boundary condition on reality. It arises from the fundamental architecture of space, time, and causality. Einstein's achievement was not the discovery of a new rule to add to the existing framework. It was the recognition that the framework itself required transformation. Time is not absolute. Space is not fixed. Motion is not simply the addition of velocities. These concepts are interwoven in ways that preserve the constancy of light speed and ensure the coherence of physical law. The limit exists because the universe is structured in a particular way, a way that forbids infinite speeds, protects causality, and links mass with energy. Every experiment, every observation, every technological application that depends on high-speed motion confirms this structure. The speed of light is not a barrier imposed from outside. It is a reflection of what the universe is. Einstein revealed that reflection. His work remains the clearest expression of why nothing moves faster than light and why nothing ever will.